5. So today we will discuss about singular value decomposition. So I just write this is not working right. Singular like this. Okay. Value decomposition. So what is the singular value decomposition of a matrix? So it's just it's factorization of a matrix into three matrices. Okay. So how does it factorize? So it has applications in data science and all like this. So how do you factorize a given matrix? So if A is a matrix, can you find such matrix such that U is M by M matrix of orthonormal eigenvectors A transpose, B transpose is transpose of N by N matrix containing orthonormal eigenvectors of A transpose A. So the difference is A transpose and other one is A transpose A. Right. And what about this sigma? Sigma is basically diagonal matrix with R elements equal to root of positive eigenvalues of A transpose or A transpose A. So it has the positive eigenvalues of A transpose or A transpose A. So it's basically the square root of the eigenvalues of A transpose A. So is this clear to everyone? These three things? We need to find three matrices to find the singular value decomposition. Okay, so how do you do that? So let's try to find out. So we just take an example. So I just try to find and then you try. Find the SVD of A is equal to 3, 2, 2 and 2, 3 minus 2. So how do you find out this? Wait, anyone is coming in? Okay. So how do you find out? First, we need to find the singular values by finding eigenvalues of AA transpose. So what is AA transpose here? AA transpose is this. Right? Then what is the, how to find the eigenvalues of AA transpose? You just solve AA transpose minus lambda I is equal to 0. So this will give you lambda is equal to 25 and lambda equals to 9. So these are the eigenvalues. So also you have to see that, okay, the eigenvalues of A transpose A are, so this is A transpose and it has two singular eigenvalues, and for A transpose A similarly you can calculate the eigenvalues of A transpose A. Similarly, but it has three eigenvalues. So A transpose A is symmetric matrix. So eigenvectors will be orthogonal. Okay. So whatever the eigenvectors you will get, they are orthogonal. So you have to solve A transpose A minus 25i, because 25 is eigenvalue. So you will end up in something like this. And which can be row reduced to this. So the unit vector in direction of it means eigenvector is basically this. Means how to find eigenvector? You solve A transpose A minus 25i such that x is 0, where x is non-zero. So this x is given by this v1 and v2 is also. And for lambda equal 9, you get the eigenvector v2 to be this, that are orthonormal. Means you have to divide by their norms to this. So what you get, these two eigenvectors, and in fact, okay, so how to find third eigenvector? How to find the third eigenvector? Basically, you need to use the property that v1 transpose v3 is 0 and v2 transpose v3 is 0. So that will give you v3 to be a, b, c, something like this, and a minus a by 2. So we got this. Like this. So you can choose a to be 2 by 3 and you get this. So this is what you have the as the eigen. So what does A transpose A look like? A transpose A, for A transpose A, the matrix is basically this. B transpose So we get V transpose as, so we have 1 root 2, 1 by root 2, 1 by root 2 0, 1 by root 18. Wait, it's just because it's transpose, so we have to take this. One by root 18 minus 1 by root 18, 4 by root 18, 2 by 3 minus 2 by 3, 1 by 3. And here you have what you now we calculate using using the formula uy 1 by sigma ABI, and this gives you. So what is basically u and what is sigma? Positive eigenvalues of A transpose A. So what is the eigenvalue of A transpose A? That is 5 and 3. So you do have only 5 and 3, otherwise there will be 0 0. That is your u, that is our V transpose, and you need to find out what is sigma. So sigma is already you have calculated using the same thing. So you get 1 by root 2, 1 by root 2 minus 1 by root 2 and minus 1 by root 2. So you can calculate what is, wait, I think u is different. U is the first one, sorry. U, and this is not, this is sigma, and this is, so this is the singular value decomposition of A. Is it clear to everyone? Like this you have to find out. So in your assignment related questions, singular values of A is basically, so singular values of A eigenvalues of A transpose. So find the singular value of one minus 1 0 2 1 2. So if A is given as, and A is, and then find sigma. So you just try these questions, use the singular value decomposition, and let me know the answers. Yes, so um, so what are the singular values of A? A is given to you as 1, 2, -1, 1, 0, 2. Then what is A transpose? That is 1, 2, -1, 1, 0, 2. Then A transpose is 3 by 2, 2 by 3. So -1, 1. So it is 1 plus 4, 5. So it is 2 and 0, 2, 4, and that is 2 and 4. So that is your AA transpose. Just find the eigenvalues of AA transpose. Right? So that will be your singular values of AA transpose. Singular values of A. Right. And what about this? So you have to find U, sigma, and V transpose in the same way that you have done before. So for this, you need to find out the eigenvalues of AA transpose, that I use the red color, and V is eigenvalues of A transpose A, and you just to make a matrix of orthogonal eigenvectors. And sigma is just diagonal at, means the eigenvalues on diagonal. So in the same way you can find this. So sigma is, what is sigma in that case? Just try to find out the eigenvalues of, I think, what is that? Sigma is positive eigenvalues of AA transpose or A transpose A. You can find out that. All right, so this is clear. Now I will move to new questions. Okay, wait a second. Okay, so you can practice more questions on that. So I just want to discuss this thing. You can try more questions, what I should say now, on the same thing. So is this A is Then you have to find then what is v in this case, and what is u in this case. And other thing is, yes, just try this question. That's all I want to do today. I will solve it. Yes, so how will you find the matrix V and U in this case? That's also easy. So we have to calculate what is A transpose A. So A transpose is for V. So that is 1 0 0 1 and 1 1. And A is 1 0 0 1 1 1. So what is A transpose A is 1 plus 1 2, and this is 1, and this is 1, this is 2, right? So 2 by 3 and 3 by 2. So that is your matrix A transpose A. So what is the eigenvalues of A transpose A? So we have to solve this determinant. So this is 2 minus lambda 2 minus lambda 1 1 equals to 0. So 2 minus lambda square minus 1 is equal to 0. It means that 4 plus lambda square minus 4 lambda minus 1 is 0. Lambda square minus 4 lambda plus 3. It implies that lambda square minus 3 lambda plus lambda, what is that? Minus 3 lambda plus 3. So lambda minus 3 minus lambda minus 3. That lambda is 1 or lambda is 3. So the eigenvalues are 1 and 3. So then you have to find the eigenvectors corresponding to lambda equals to 1. So you have to do A transpose A minus, so that are the eigenvalues of A transpose A. So how do you do that? So for that you need to find out transpose of n by n containing orthonormal eigenvectors of A transpose A. So A transpose A is symmetric matrix, so it has to be orthogonal. So eigenvectors will be orthogonal. The other thing is that you need to find out the eigenvectors basically. So what is A transpose A minus I? Minus 1 times I, because eigenvalue is I. So we have to find x such that x is non-zero. So what is A transpose A minus 1? So that will give you 1 1 1 1. So what is x in this case? X is something like 1 by root 2 minus 1 by root 2 is orthonorm, is a unit eigenvector corresponding to lambda equals to 1. All right. And other is similarly solve A transpose minus lambda I is equal to, A transpose A minus lambda is now 3. X is non-zero again. So what is A transpose A? Then after getting minus 3, then minus 1 1 1 minus 1. X1 x2 say. So what is x1 x2 in this case? 1 1. So I will take the norm divided by norm. So that will be unit vector corresponding to lambda equals to 3, right? So what is V? V is basically 1 by root 2, 1 by root 2, 1 by root 2, minus 1 by root 2. And what is V transpose? V transpose is 1 by root 2, 1. V transpose is same. So that is your V. So if you see, then this will be your V. Right. Similarly, you have similarly you can find out U. What is U? Anyone? What is U? U is A transpose A. Is it right? No, A transpose. So you have to do the same process for this. All right. And what is sigma in this case? Sigma is the eigenvalues of A transpose square root. So that will be 1, 3. It will be 1, 0, 0, 3. So that is your question, and you can do the same process to find out what is U in this case. Is it clear, everyone? Singular value decomposition. Okay. So if it is clear, then I just want to do that today. Thanks. And diagonalizable matrix I've already discussed, I think.
Excuse me, sir.
Yes, yes.
So sigma means root of lambda.
Yes, it's the square root of the eigenvalues of A transpose A or A transpose. Okay.
Yes. Then in this case, root 1, root 3 sigma.
Oh, is it? Wait. What we have calculated this? Yes, I think. So in the last example, if we see here, then what we were getting? Yes, you are right here. Root 1, root 3. So 1 root 3. Right. Yes, sorry. Because it's 3, so it's just square root. I think the questions in your assignment are based on that. Some questions. Any doubts other than that? Is it clear? Singular value decomposition, everyone?
Yes, sir.
Okay. So you have last tutorial, I think, next week. We do have 1 hour practice question session, maybe. Yes, if you have any questions, you can ask.
Excuse me, sir.
Yes.
Sir, here A is 3 by 2 matrix.
Yes.
Then sigma also 3 by 2 matrix.
Why is that? Wait. What is sigma?
Here
Okay.
sigma is the diagonal matrix of
With
the same
okay.
order as A.
Right. Wait a second, I have confusion. I think with sigma. So in that case, in the above example, we do have the sigma as, yes, it's the same dimension with A, right? Yes. Okay. And we say this. See. Yes, so you have to ultimately make A, so you have to check the dimensions, right? For U, what is the dimension of U? What is the dimension of U? And dimension of V transpose in this case, what is that? So here the dimension of V transpose is 2, right? It is 2 by 2. And what is U? Dimension of U? I think that will be 3 by 3, 3 by 3, 2 by 2, and in between you have to fill the box. Right. In that case, you will have 3 by 2. Yes, you're right. So it should be 3 by 2. So in that case, you have 3 rows and 2 columns. Is that all right?
Okay, sir. Yes, sir.
Yes. You have to check the dimensions then. Okay.
Sir, can you explain the 10th question in assignment?
Yes, let me see. The 10th question is, okay, there exists a non-diagonal matrix A which is diagonalizable over R and which is such that A cube is identity. Okay. So you have to, so what is the characteristic polynomial of a matrix which such that A cube is identity? Anyone? Yes.
X cube minus trace of x square plus
So
the
it should
determinant
be,
value.
uh, the characteristic polynomial should divide x cube minus 1. Either it is x minus 1 or it can be x squared plus x plus 1, right?
Yes, sir.
And it is not factorizable. And this is factorized. So if characteristic polynomial is x minus 1, then it will be identity matrix, right? Why the pen is not working? Yes. So it can't be x minus 1. So the only possible choices are x squared plus x plus 1 or, and which is diagonalizable over R. Okay. And other choice is x minus 1, x squared plus x plus 1. Means x cube minus 1 basically. So yes, I think there exists such matrix. What do you think about it?
But the eigenvalue, sir, belongs to complex. So it is
Yes.
not diagonizable over R. It is diagonizable over C.
Over R, why it's not diagonalizable over R?
But all the eigenvalues, sir, belongs to complex numbers.
What does it mean then?
It is diagonizable over R.
Means yes, it is diagonalizable over C, but why it's not on R? That's not the reason you are saying. The only eigenvalues are complex. Okay, I think it should be diagonalizable over R. Okay, let me check. Um, why it's not diagonalizable over R? So you are saying that eigenvalue is not real? All the eigenvalues should be real?
No, sir. All the real eigenvalues are complex numbers. Whatever you
Yes.
consider example,
Yes. What is the definition
we
of
call
diagonalization?
diagonalizable means we will get the distant eigenvalues,
Distinct eigenvalues, yes.
or it is similar to diagonal matrix.
Yes. But what
But
is
here
the
all the eigenvalues belongs to complex numbers. I thought so. It is diagonalizable over C. That's why I'm
yes,
asking it is true or not.
it's diagonalizable over C. That is very true. Yes. But for R you have to check it. So you have to find such a matrix A which is not diagonalizable and which satisfies A cube is equal to identity. Okay, check it. So I can take this maybe this type of matrix. Does this satisfy A cube is equal to identity? Can you check this matrix is diagonalizable or not? Diagonalizable. Is this diagonalizable? That is not diagonalizable, right? It is not similar to a diagonal matrix because it is an upper triangular. Yes. So you have to basically prove it, right? You are right. It's there does not exist such matrix. So A is A cube equal identity such that A is non-diagonalizable. Sorry, there does not exist A such that A cube equal identity and A is diagonalizing. Can you prove that? How will you prove it? That's not the reason you are saying that eigenvalues are complex. Okay, to check the proof, but it's true that it's not. So you can take this matrix also minus 1 by 2 and root 3 by 2 and minus root 3 by 2 and minus 1 by 2. So in that case, I think this is also non-diagonalizable. I think so it should be. So that is also, yes. Can you check this is a diagonalizable matrix or not? Yes. Is it diagonalizable? I think so it's diagonalizable. Then there exists a counterexample. Yes, Bhagya, you were asking, can you check is it diagonalizable or not?
Yes, sir, I'm checking.
Okay. Root 3 by 2 minus 1 by 2. It implies that there should be a basis of eigenvectors of A.
Yes, sir, it is diagonizable and its eigenvalues are real.
What are the eigenvalues? Yes, it's diagonalizable. So you can find out some matrices like
Minus
that.
1 plus root by 2, minus 1 minus root 3 by 2. But here
Okay,
I want to check if cube is identity or not.
okay. What are you getting is identity here. You can check. What is A square in this case? 2. I think it is identity. You can check its identity.
Okay,
AQ.
sir.
Okay. All right. What does it? Yes. So I'm done with today. Thank you. I stop recording now.